Okay, here we go. It is time now for Pre-Calculus Online Lesson number 1. This lesson is a big one. I wish that we weren't starting this online learning business with such a huge topic, but here we go. We can figure it out. Today we're going to start talking about sine and cosine waves. This is a big enough deal that it's probably going to end up being 2 or 3 videos. Hopefully only 2. We'll see. So, we're going to start by reviewing the unit circle a little bit. Unit circle, I'm going to come over here. Unit circle was a way for us to very quickly, very easily, no real effort required, find sine, cosine, and tangent values for the most common angles, the 30s, the 60s, the 45s, all the way around the circle. So hopefully you have a unit circle handy, and I don't have to just make this one up. If you do not have a unit circle handy, just open another tab in your browser and Google unit circles so you can look at this. I'm not going to create the whole thing on video. You know what it looks like. Google's a thing. But the benefit of the unit circle is you can look at it to figure out sine, cosine, tangent values really quickly. So for example, if I wanted to know the sine of 0 degrees, pretty quick to figure out that that's 0. Actually, no, never mind. I'm not going to use degrees. We're well past degrees. I'm going to use radians. Sine of 0 radians is 0. Pi over 6, we're going to get 1/2. Pi over 4, we're going to get root 2 over 2. Pi over 3, we get square root of 3 over 2. Pi over 2, we get 1. This is the first 90 degrees, the first quadrant of the unit circle. I'm going to keep going around the circle, getting the sine values in a big list. I'm just going to start skipping the 30s and 90s to condense this list a little bit, because space is kind of obviously an issue. So after this, I'm going to go to 3 pi over 4, and I'm going to get root 2 over 2. Then I'm going to go to pi and get 0. At 5 pi over 4, I'm going to get negative root 2 over 2. At 3 pi over 2, I'm going to get negative 1. 7 pi over 4 will give me negative root 2 over 2 again. This is in the 4th quadrant now. And then all the way back to the positive x-axis will be 2 pi for a sine value of 0. So, these angles are all readily accessible on the unit circle. You can look at these angles, you can get sine values very quickly. That is the power of the unit circle. You have all of this information easily available. Here's what I'm going to do with this information. This thing that I have created hopefully looks suspiciously like a table of values, because it's a table of values. These are going to be my x values. This is going to be a sine of x. I'm going to say y equals the sine of x. The bad news is this is a function now. I have x and y values. I have a table. I'm going to graph this function. These are my x values. And again, this is in radians. These are my y values. This is the sine. Let's see if I can write that a little better. Y values. Y equals the sine of x. Before I start graphing this, I'm going to need to know what some of these values approximately are. Square root of 3 over 2 is nice as a precise value. There's no rounding involved. But if I'm going to plot it on an axis, I need to know about what it's equal to. So I will say that this 1/2 we know is about 0.5. Square root of 2 over 2 is about 0.7. And this thing is about 0.84, I think. Maybe it's 0.86. I don't remember. You can look it up. I'm going to go with 0.86. This is 1. This is, again, 0.7. 0, negative 0.7. Negative 1, negative 0.7, and back to 0. So, this is approximately where all of my y values are going to sit. Again, they're all in between 1 at the very, very biggest, very most positive thing we can get out of a sine is 1, because sine is on the unit circle. The highest y value on the unit circle is 1. Lowest value on the unit circle we're going to get is negative 1. That is the bounds on our sine function. Can't be bigger than 1, can't be less than negative 1. In terms of the x-axis, I need to know where these things sit. 2 pi, I'll say, is about 6 1/4. We'll put that right here. Pi then goes here. I'll put 0 right there. That's where 0 goes. Pi over 2 is going to be here. 3 pi over 2 is going to be here. And the rest of these things are going to fall somewhere in the middle. I think this is enough to approximate about where everything's going to sit. So, I definitely have the point 0, 0. Wish I had stolen a different color marker. Having just green available is not ideal. The pi over 2, I'm going to be up here at 1. In between, I will be at, this is pi over 4, I'll hit 0.7 right here. 0.8 and 0.5 will be in the middle there. At 3 pi over 4, I'm going to be back to this 0.7 number. It's about right here, I think. And then back to 0 for pi. Here's negative 1. Here's negative 0.7. So at 3 pi over 2, I'll be down here at negative 1. I'm going to hit negative 0.7 in between these guys, and then I'll be back to 0 at 2 pi. Now we get to play a game of connect the dots. And we get something that looks like this. And this is a sine wave. So on the weekly sheets, I've described the trig that we're doing in terms of 3 different flavors. I say we start with triangle trig, that's the basics. We all know that sine is a ratio of opposite over hypotenuse in a right triangle. Then we go to circle trig, which is what you guys have been working on lately. And then finally, wave trig. This is top tier trig. This is where we wanted to be, because now the sine, it's not a ratio, it's not a y value on a circle anymore. I mean, it still is those things, but the most entertaining, exciting thing that we can treat a sine value as is a function. That's what precalculus is all about. The whole point of precalculus is playing with functions, and now we have the sine as a function. What I have drawn of this is only a piece. We all know about coterminal angles. I know that there are angles that are bigger than 2 pi. We could keep going from 2 pi to 4 pi. We're going to get a shape that replicates this, because all of those angles, if you keep doing angles around the unit circle, you end up with things that are coterminal with all of these angles we already have. So you're just going to repeat this shape again. I don't have room, but it's the same shape that way. And it keeps doing this shape forever. Sine of x is called a periodic function because it repeats very consistently with a period of 2 pi. Every 2 pi. It makes the exact same shape. Does this wave up to 1, down to -1, back to 0. It also does this in the negative numbers. Forever in both directions, this function does the wave, I'm making gestures, not on camera. It does the wave gig forever in both directions. There we go. Still getting used to the camera. So that's what is meant by a sine wave. That's what's meant by a periodic function. Cosine looks almost exactly the same. Let me erase all of this and then we'll draw a cosine wave. Okay, first thing I want to say about this cosine wave business is that you have to be careful not to get confused about what is meant by x and y, because this is changing a little bit from the unit circle. When we're talking about the unit circle, the cosine is the x-coordinate of any point on the unit circle, and the sine is the y-coordinate of any point on the unit circle. So we have this association that x equals cosine and y equals sine for coordinates on the unit circle. That is a thing that we do. Hey Harley, you want to be in the video? No. Here we go. Okay. Harley says hi again. What we have to be really careful about when we're doing trig functions is that the sine equals a y value, cosine equals an x value thing doesn't really apply anymore. When we're talking about wave trig, sine and cosine are always your dependent variables. They're always going to be your y variables, are the sine and cosine, and your x is always going to be an angle. So we're switching these things now. If you always make sine a y value and cosine an x value, you always get a circle. If you want, Harley wants down. Okay, bye. If you want a wave, your angles have to be your x values, your independent variable, and your trig function always has to be the y value. So, it might look weird to see y equals cosine of x, but that's a new thing to get used to. So, I'm going to use almost all the same points here. I'm just going to do the multiples of 45. So pi over 4, pi over 2, 3 pi over 4, down to pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. This is the 9 points that are my multiples of 45-degree angles. Okay, and if you're looking at your unit circle and you want to find the cosine of these angles, you can see that this is 1 root 2 over 2, which is again about 0.7. This is 0. This is negative root 2 over 2 in the second quadrant. This is negative 1, negative root 2 over 2. This is, 3 pi over 2, this should say. This is 0 here on the negative y-axis. This is positive root 2 over 2 in quadrant 4, because we're dealing with the x values on the unit circle. And this is 1. We're back to 1. So, Again, x-axis is radians, y-axis is the cosine of that. If it makes it easier to think of this as a theta axis, you can totally do that. And again, I will say that right here we have 2 pi. We'll put pi right in the middle. This will be pi over 2. This will be 3 pi over 2. And then the pi over 4s will be in between those things. So we start at 0 degrees here at 1. And then we go to 0.7. And then we hit 0. And then we're down here at -1 by pi, which means right in the middle we're going to hit 0.7. -0.7 there, 0. +1 over here, 0.7 in the middle. Slide that up just a little bit. So, once again, it's time for a rousing game of connect the dots. We're going to come down here and back up. This doesn't look like a wave, it just kind of looks like a parabola. But you have to remember that the cosine is exactly as periodic as the sine function. If you keep going, it's going to repeat this shape over and over and over again. So past here, turns down, over here it turns down. It's going to keep on doing this wave thing. Honestly, it looks almost exactly like the sine wave, just shifted a little bit to the right or left. Sine starts at 0 and goes up. Cosine starts at 1 and goes down. That's how you can keep those two lines separate. I'm going to cut this first video here because I don't want to reshoot all of this if I say something stupid while talking about the next big topic. So, end of part 1.